Okay, then let's get started with the third practicals. I'm back, and together with Julia, we will do the practical session today. So let's get started. What is our plan for today?
Well, as always, we have many things planned. I think uninitialized variables you already heard in the lecture. We'll recap that a bit, and we'll also show you Valgrind, because it can also be useful in A1. And if you don't, if you got some Valgrind errors with your test report, you should probably look into it, because there's something wrong with your code. Additionally, we'll talk about input of characters. You might think that you already know about that, but we have some new concepts there that you might not have noticed until now. And then, of course, from last lecture, we'll talk more about functions and also something new, the stack, which you'll learn today.
So in particular, the topics about the functions are also very relevant for assignment 1, also how to structure a program. Also, this is something that we will talk about today. Let's get started with the organizational matters first. As you hopefully all know, assignment 1 is already out since last week, and you have one more time to complete assignment 1 until next Wednesday in the evening. One remark that we often already told, but we also want to tell it one more time, when you work on assignment 1, please push regularly to GitLab. Just don't wait until everything is done and nice and then submit your last version. But please, whenever you complete a new feature in your assignment, then push to GitLab that there is always some version on Git, and that it cannot happen that there are some problems on the last day and you're not able to submit your last version.
Yes, I think I already saw the question somewhere, if you can submit multiple times. And of course, we'll only grade the submission you handed in, the last submission you handed in before the deadline. So you can push as many times as you want. You can do hundreds of pushes to GitLab. We'll only grade the last one before the deadline. And I really recommend you to do it, because you already had it multiple times that there's now some issue with the computer, with the virtual machine, and we have some crashes, and then if you lose progress, that wouldn't be fun, so try to push regularly.
One more thing, Julia announced this a few days ago on Discord. We also offer a ranking. Since I'm not connected to Eduroam because it's not working here, down here, very good. I cannot show it now, but no internet, sorry. But you can compare there with other students and see how many test cases do other students pass, and some other statistics as well. Currently, we have seen by the ranking that approximately 200 people submitted something for assignment 1, even if it's just a preliminary version, and we would like to increase this by a lot. This is not even half of the people registered to the course. And one more thing about assignment 1, next Monday at 14 o'clock, there will be a question hour in a rather small lecture hall in the Infeldgasse, HSI 3. And there will be like 2 hours are planned for the question hour. In the first about 30 minutes, we will also have a very brief KU session, which will not be recorded, but we will just do a recap of the most important things of assignment 1, and then you have the possibility to ask questions, so general ones that are interesting for many students, as well as individual ones if you have a problem when you're coding, and we should have a look on that. So you get really individual support there.
Yeah, so there are multiple tutors there which you can talk to. And they will answer your questions. Also stuff in your code that you can't ask on Discord, the question how you can ask it then.
Of course, it is optional, so you don't have to attend it. In particular, if you're done with assignment 1, probably there's no need to go there, but if you struggle to do the assignment, probably it's a good option to take into consideration. And one more thing about the mentoring program. As you hopefully also know, you are assigned to a mentor, so groups of approximately 10, 20 students are assigned to a mentor that are not tutors like us, but they are people that are studying computer science as you and are happy to help you. And probably all of you got now contacted by your mentor and they are waiting for you to answer them, because give them a brief update, what you have done on assignment 1, do you need any help, is everything clear? Because they should work with you, but if you don't respond, they can't work with you.
Yeah, so they are just students who already passed ESP, and they are there to help you if you have any questions.
Okay, that's about the organizational matters. Then let's get started with our first topic, uninitialized variables and Valgrind.
Yeah, so does anyone have an idea what the output of this code snippet could be?
Okay, so what do we have here? We have an integer a, and then we print the integer a. Okay.
Yes? Sorry, can you repeat it? I didn't hear it. No, it wouldn't output the memory address. Yes, it would output something. Yeah. No, not the ASCII value of A. Yes. Yes, exactly. I think you meant that too, right? So what is the output? Well, it's undefined behavior. Because we didn't initialize it, we didn't assign any value to the variable, therefore there could be any value stored there, just that anything that could be there previously in memory. So yeah, always initialize variables, because it could not be that, it could be less obvious in this example.
And if you don't trust us now, we can also have a look on the code. So we've prepared this example here, and if you compile, okay.
Yeah. So and just some value.
Run it again. Maybe we get something different. Okay. So if you don't initialize it, anything can happen.
Now, of course, I got a second snippet again with a variable a, now with a for loop, which just, I wrote it here in a comment, so it just adds the numbers we iterate over.
Who trusts that this is 10? Who thinks that this is 10? Who thinks that something else is the output? Okay, so the majority says something else.
If we can try it again.
Also prepared this, yeah. Exactly, yeah. The value of a wasn't set, and for that reason, even if we add 10 to something, the output is something we don't know. Yeah.
Yeah. So it's basically the same example as before, just that we now add some numbers to the random number we get. And you can imagine that you can do this very complex, so that you somehow declare the variable somewhere in the code, and then especially with functions somewhere down the line, later on you try to use it, but it was never initialized. Maybe mix in some if statements, and then this can get really confusing. But well, how can we somehow detect this? And yes, that's one reason why we have Valgrind. And Valgrind is a tool to detect memory leaks and errors, primarily. You don't know what this is yet, except for that the uninitialized variable is some kind of memory error. There are many more that you'll learn later on in this course. So for assignment 1, you only need to watch out for uninitialized variables. How do we use Valgrind? Well, we compile with the -g flag. As we said last time, you need this for if you want to debug your program, and Valgrind also needs this, so that because it also kind of debugs your program, so it knows where in the source file corresponds to which parts of the compiled binary. And yeah, how do you run it? It's just Valgrind and then your program. Sometimes it doesn't work if you don't put the // here, so yeah, watch out for that. And of course, you can always read how Valgrind works in our guide in the Notion. Oh, I can't open it
No,
now.
you can't open it now, but you can demonstrate Valgrind if you like.
Yes. So let's try it. I didn't compile with -G, so I'll add this. And then I'll run Valgrind main.
So now a lot of things are happening. It's getting even longer. So if you have such a long error message, always start at the top. This is probably the best approach to do so. And what is written there now?
Well, the first thing we have is the use of uninitialized value of size 8. And well, it already tells us that it's in the main function in uninitvar.c. That's how we named the file at line 14. You can, if you look at this, these files here are not files that we've just written right now. So you can mostly ignore them because they are part of what printf internally uses. Yeah, so only this C file here we wrote ourselves. So we look here at line 14. And we can see that, yes, this is exactly where A is used. And Valgrind tells us correctly that this depends here on an uninitialized value.
And if we fix it now, if we maybe initialize the A and compile it again and run it again with Valgrind, then we see here.
Yeah, we see that it also prints what our program prints. And it says...
in the very last row.
Yeah, here 0 errors.
And if you have errors in Valgrind, this is also displayed in the test report in assignment 1. So if you see there, okay, Valgrind errors or memory errors 10, then probably this is your problem. And you can also view the logs in the test report if you click on them, and then you hopefully find the problem, or you can also ask us for instance, in the question hour.
So it's in the table at the top of the test report. There, for each test case, it states if there are any memory errors or memory leaks. And then exactly this log that you see here, that we get in the terminal when you just execute Valgrind, you also get as a txt file in our pipeline. So you might have noticed if you look at the test report.html, you get from our pipeline online, where you also see the private test cases. Then there are also some log files which contain exactly this. And you can then use these log files to find the error in your program. And yeah.
Any questions regarding uninitialized variables or Valgrind? Then we probably explained it well enough. Then let's get started with our first real topic. So in assignment 1, you will mostly deal with the input of integers. And now today we will talk about the input of characters and also discuss the input buffer a bit. But let's see what this is. And today we will do this and discuss these topics by implementing a rather large program for a practical session. And in this program, we will read an input. Okay, that's not surprising now. And we would like to scan through the input. So scan through all the characters that we entered. And we would like to find the largest digit that is contained in the input.
Yeah, so not only the largest number, just the largest digit. So, for example, if you input 1,4, then the largest digit would be 4 and not 14.
So we even have examples here, yeah. So if we have a look on our course, ESB, winter semester 25-26, then 6 is the largest digit appearing in the output. Or we're 2 minutes too late now. 1543 would be the largest digit, a 5. Okay. Now I have a question to you, and answer honestly. It's no problem if the answer would be no. Who believes to be able to implement this in C in 20 minutes? Okay, yeah. thank you. It's no problem if you don't think this is possible. You will see now, and after this session, you will be able to do this in 20 minutes. Okay, so the first question would be, how can we read a character? So probably this is an easy question. You should have heard it in the lecture. First thing, if you scanf %d, as you did in the assignment, this doesn't work. Why does this not work? Maybe someone else, yeah?
Mm-hmm. You?
Please a bit louder. Yeah. Yeah, so this is the d, waits for an integer, but we could also enter any characters, not only digits, as we've seen in the examples before. Okay, so we need to read single characters, and we have seen two options, hopefully in the lecture. The first option is to use getChar. This is also a function like scanf or printf, and getChar returns a character, namely exactly the character that we typed into our program. And the second option, probably you're more familiar with that, is if you use scanf and then %c, because %c is the placeholder for a character. So from this, we know how to read in a character. Okay, so maybe we can implement this now. So let's get rid of the uninitialized variables and maybe try a bit. So what do we need? We need probably a character variable where we store the input in. So let's call this input character. And we should probably initialize it to something. I don't know, initialize it maybe with a small a. Okay. And then we could, to make it a bit more beautiful, we write something like, please enter an input. And then in the next line, we also write this input symbol that the user knows, okay, he needs to enter something. And now we call getChar, and the return value of getChar is the read in character. So this will be stored in input character. And now we can read something, but we would like also to check what is read in. So probably we should also print this. I will print this in a bit more beautiful way. So I make here a separation line also here. And in between, I will just print the output. And %c, because we read in a character. Okay. And we also need to specify which character we would like to output. So, okay, we have the prompt, we read the character in, and then output it in a more beautiful manner. Okay, let's see whether this works. Okay, I compile now with warnings, maybe name it main, and we need to compile now, okay, main.c is the file, and we run this. Okay, please enter an input. What should we enter?
Maybe just press I for ISP.
I for ISP. Okay, and the output is I.
Yeah.
Everything working perfectly.
So maybe the first thing you noticed right now is that after just pressing I, nothing happened.
Okay, yeah.
Maybe that's the first thing to observe here.
So if I press I, okay, nothing happened.
So even though the function is called getChar, somehow just typing one character does not give us the character.
So we type the I and then the enter, and then, okay, then we have the output. So maybe we could ask, what happens if we call getChar one more time? So I will just repeat this here. Just copy it now. Don't use any loops at this moment. Maybe name this now output 1. And I name this output 2. Okay, and compile it again. And we run it. So let's type again, I for ISP, and press enter. And what is happening now? So output 1 is still the I, okay, this is as expected, but output 2, why is this like this? I didn't even have the opportunity to enter a character at this point.
Yeah, so maybe you can only enter one character per program.
Okay, should I try it out if I have a third output here maybe? Output 3, I read in one more character, compile it again, run it again, I for ISP. Okay, but now I don't print the prompt now, but now my program doesn't terminate, so I could enter one more character at this point. So an S, for instance. Okay, and output 3 is the S. So this is kind of awkward, what's happening here. Okay, so maybe it's best if we view this in the picture, what is happening here. So we have now different characters here in the examples typed before, but if we have the first get char, what do I type in? What was it? The Q was the laser pointer. Okay, if I type an A and a \n, or the I and the \n, then the \n should indicate that I need to press enter when I enter an input. So I actually type 2 characters. And then both characters will be available for our program. So if we have this as a list here, the first character is the A and the second character is the enter that I pressed. And now the first character is the one that getChar returns then. And this is the output that we see. But the enter character is then still contained in this input buffer, yeah, because we press those 2 keys and it doesn't magically appear, the \n. So when we call getChar for the second time, then our program says, wait, I have one more character here. The user already entered something more. I don't even need to ask the user for more input, but I can just read the next character that was typed before. A second, please. And then when I call getChar a third time, then we have already returned these 2 first characters by getChar. So there are no more characters left. So the program says, okay, no characters left. I need to make the user able to enter something again. And then we can type, for instance, X, Y, and \n. So the \n is again the enter key. Then these 3 additional characters are stored in the input buffer. The first one is the one that we look at. That is what getChar returns. And the next 2 remain in this buffer. So if we would call getChar for 2 more times, then the Y and the \n would be returned. And only in the 6th call to getChar, we would be able to write again something into the program.
Yeah, so maybe the 2 key observations we have here is that, well, for one, we can only somehow enter a whole line at once into our program. So if we have to enter something, we always have to hit the return key so our program continues. Okay. And then the second observation is that we get only asked to type in something new once this input buffer is empty, or so to say, has no new characters for us.
Mm-hmm. You had a question, or is it already answered? Answered. Okay. Any further questions to this input buffer part? So this will be also important then in assignment 2, and maybe the lecture even talks about it today, next week. Okay. Okay, but if we do it like this then opens the possibility that we then read an input until the enter is entered, yeah, until the \n, and then we can find the largest digit. So how can we do this maybe?
Yeah, so so we already said what our goal is today. We want to write this program that just returns us the largest digit that we have entered. And well, what do we need to do? We need to repeatedly read characters, but we don't have to store them somehow because we can just use the input buffer. So we've asked the user once, what what to read. And then with Getcha, we just go through the input buffer and handle each character one by one. And how long do we need to do this to go through the input buffer so that we don't ask the user again? Well, we just need to read until we get the \n, so the new line. Because when the Getcha returns \n, the next time we would call Getcha, it would ask for new input, because we always end our input by pressing the return key. Yeah, and how can we do this so that we don't have to store all these characters and then somehow find the largest one? Well, if we want to just find the largest one, we can only store the best digit found so far.
So we only need to store exactly one digit and not multiple.
Yeah. Okay.
Then let's start programming, I would say.
So we said we always just want to remember what was the largest digit we found so far. So I'll call this largest digit. And well, to what do we want to initialize this? Well, I just want to store the ASCII value of this digit, so I won't be converting this to an integer, just a character. But if I just store 0 here, then, well, if there are no characters in the input, we would still think that 0 was the largest digit, and we don't want that. At the end, we want to check if there were any digits even in the input. So I just subtract 1 from it. So this would now be not a valid ASCII value for a number, but it's still a valid ASCII value that we can store on the character. Yeah, what's the next thing we want to do? Well, we now want to ask the user for input. So we'll do something like this. Just enter an input. And now, well, the user did not enter just yet an input. What we want to do is then we want to iterate over the whole input. So we want to call Getcha repeatedly until we are at the end of the input. So, well, let's just create a loop. How long do we want to loop? I do not know yet, so I'll just do, okay. So I'll just do.
But you can change the keyboard layout, I think.
Oh, okay, thank you. Yeah. And then we can read the input, maybe something like current character, and then we call Getcha. Okay, so maybe I'll just try this now to better illustrate what I want to do. Yeah, some warnings, okay. As we've seen before, if I just now enter some long input and then press enter, this Getcha will, at the first execution, when we in the first iteration of the loop, return the L, then it will return the K, then the S, and we want to loop until we are at the end of my input. So if the current character is the \n, so the new line character. So this means the user pressed return, then we want to break out of the loop. Yeah, I think this should work. And then, okay, so now we have, yeah.
Maybe we can even show now if this works. So we have now.
So if I would press enter previously, we would be repeatedly asked because we never exited the loop.
So this was the version before we entered the break because we didn't compile again. Mm-hmm.
Yeah, and if I run it now again, maybe also some digits, then yeah, then we actually exit the program, which means we got to the return 0, which means the loop here with the while 1 did not run forever. And this means we actually hit the break here and got to the new line character. So now we need to somehow check, because I also entered some other characters here, what actually is a valid digit. And does anyone have an idea how we could do this to check if this current character we just read is a valid digit? Yes? Okay, yeah, there are only 10, so we could, of course, spell them all out somehow. Yeah? Yes, exactly. That's what we'll do now. We have something installed to see the ASCII table. What we can use here is that we know that in the ASCII table, if I find it, here, that's the characters 0 to 9 are after each other for the ASCII values. So 0 is 48 and 9 is 57. And by that, we can just compare and check if the character is anything between the 0th ASCII character and the 1 for 9. Yeah, so what does this mean? Well, the current character needs to be bigger than the 0. So what we have here, bigger than 48. And the current character also needs to be smaller than the 9. So yeah, 9 is the last, is 57. Okay, and now we need to update if we found a new digit which is larger than the one we previously stored. Well, then we just need to update our largest digit. So what I'll do next is, if the current character is larger than the largest digit, here we can again use that the ASCII value of these characters are stored after each other in the table. So this comparison actually does what we want. So 9 is bigger than 8, is bigger than 7, etc. So we can update our largest digit to be the current one. So okay, we loop over this. If it is a valid digit and the digit is greater than all of the ones we previously saw, then we'll update it. And I think everything that's left is just to print this digit.
Then we print the digit, and then we can also verify whether this is true, what we have done, and if this is working.
Okay. So
maybe compile it first.
We need to compile. So maybe let's try some example that we had before, something like this. Now we would expect 6 to be the largest digit. Let's press enter, and yes, we get the 6.
Maybe at the \n after the printf that the percent sign is disappearing. This just indicates that we forgot the %n, at least in my terminal.
Oh, now I put a D there.
But maybe this is even interesting, yeah?
Yeah.
What happened if we put the D there in the printf? So if in the printf there is the D, then we don't print the character, but we print the integer value that is behind the character. As you showed before in the ASCII table, each of these characters has also a value, an integer value, and for the 6 it would be the integer value 54. And for this reason, if we interpret this character as an integer, it would be 54. But we would like to have the character representation of this number. So if we print it with %c, then we get the 6, hopefully. Yeah.
Yeah. Okay, maybe let's try one more time. What happens if we do not enter any digits? Because we had this check up here. Yeah, maybe let's run it. And we can see that, okay, now the largest digit is somehow this slash. Why would this happen? Well, if we look here, the 0 is the 48 and the 47, which we effectively store here in the largest digit, is the slash character. So therefore, but we do not want to print this, so somehow I now want to check if we actually found some digit, and that's why I did this here before, so we can actually differentiate between the largest digit in the input is a 0 and there were no digits in the input. Because as we see, if there were no digits in the input, we get the slash. And what I'll do is now just check if the largest digit is bigger than the ASCII value 0. Because then I know it's definitely not 0 minus 1. And else we know that there were no digits in the input. Oh.
Maybe some percent \n at the end.
Okay, please enter an input. Now something without any digits. And then, yeah, we get no digits in the input.
So this is working now very nicely. Maybe just one more thing about this concept that we are using here. We iterate over multiple values, and we want to find the largest value. So we can keep a variable that stores the currently best one, and if it is larger what we see, then we make an update to the larger one. And you will see this will come very often. The important thing is how you define the start value. If you want to find the maximum, the largest value, then you need to choose the start value smaller than all the values that appear. Because if we would choose this now to be 9 plus 1, for instance, then this would be always larger than whatever value we can read. So it's really important that this is smaller than everything that is appearing where we want to find the largest value of.
Yeah, and because of our check here with this if, only digits within this range are appearing. So this will never appear, even if we enter it, because then this if would be false. But now I would argue that I didn't write very good code, because this while one here with the break is somehow, it's not that easy to really see on with the first glance what's going on. But even though I just wrote it like, I don't know, just how we would say it. So we need a loop, and then I just wrote something there, and then on our condition I want to break. But I think it's a bad idea to just replace this with directly with a condition up here instead of looping forever and then breaking.
Okay, maybe we can do this.
So I could use a while loop, of course, like I did here. But as we know that we want to at least call this sketcher once, I will do a do while, so that the body is executed once. And then we check if we want to loop or not. And what do I want to check here? Well, I want to loop until the end, and our end is the current character, is if the current character is the new line. And I can delete this break. And now we see something that we already discussed in the last practical session, namely that here in this while it says current character is undefined. Why does this happen? Well, the current character just lives within this while loop, and this condition here is not in the while loop, so we can't access current character. So what I'll do is, before the while loop, I'll do char current character, and then just initialize it to something. And now I can access current character down here because it's accessible in the whole main.
And now this is more beautiful because now the while loop is actually related to the condition when the loop is stopped. Yeah, before it was like this infinite loop, and at some point we had to break and stop the loop. But now, really, in the condition, in the while condition, it's stated when the loop terminates. So we would consider this to be a better style than before. One thing. Second thing, the code got even shorter now.
Yeah, and maybe one more thing, we have two ifs nested here, and of course, we could just do this in one, if we in here say current character is bigger than largest digit, then we don't need this if here, because it's already checked with this one up here.
So you can chain multiple ends together, and you don't need to have them in nested if statements.
Yeah.
So also this implies that your code is not moved to the right side so far. You have so many indentations, so many nestings, but it's getting a bit cleaner now with that.
Maybe now a bit more of a tricky question. Are all three of these conditions that we have here, so we have current character bigger or equal to 0, and current character smaller or equal to 9, and current character larger than largest digit, are all three of these checks really necessary? Or so to say, is there any check within one of those three that we can avoid, that we don't need?
Maybe we wait for someone else. You already answered a few questions. Yeah. Here.
Mm-hmm. It's the right answer, but not the correct explanation why it works. Yes, you? Yes, exactly. So you are right. The current character check here is not needed. But the reason why it's not needed is because in here we already check if the current character is larger than the largest digit. At the beginning, this is 0 minus 1. So, and here we have a strictly larger than operator. So it needs to be 0 or more. And then afterwards, when we only ever increase the largest digit, so we don't ever need to check if it's below 0 again.
I don't fully understand why the while condition is equals new line character. Isn't that the last character of the string?
Yeah, you're right. It's not. Yeah, it's not equal to new line character. We want to loop until we are at the end, so until this is false. Yeah, you're right.
So we want to break if we have a new line character, but we would like to loop as long as we don't have one.
Yeah.
Okay, then maybe try whether this still works with the modifications.
Okay. And yes, this works.
Okay. Maybe we can even add a small extension to that now. So currently, continue onto the slide. Currently, we can only add one input, then we process the input, find the largest digit, and then we terminate the program.
Yeah.
Maybe it would be interesting, can we also implement it in such a way that we enter something, we print the largest digit, and then the program asks us, do we want to enter another input? And then we can answer yes or no, and if we enter no, then the program terminates. If we enter yes, then we will ask again to enter something. It again will print the largest digit, and then we will again be asked whether we want to do this one more time or if we would like to stop.
Yeah. So our user might want to input multiple inputs to check what's the largest digit in there. So you already explained it. We want to support these multiple inputs without restarting the program every time. So what do we want to do? Well, after we printed the largest digit, we want to ask, do you want to check once more, or do you want to enter one more input? And then we want to repeat, and if no, then we want to exit. Yeah.
Yeah. So basic idea is very simple. Put everything into a loop, right? So everything that we've done so far should be repeated multiple times. So we put this into a loop.
Yeah, so I'll just go here, grab the whole main, and then do another do while loop, because we of course want to do it at least once. Now, of course, we need to look out, because now here the indentation of our code is not correct.
So if you mark everything and press tab, then it moves inside. Please don't leave it. If you add something like a loop outside, then don't leave it unintended, because Daemon cannot read your code when we correct your submissions.
Yeah. So, and what do we want to do? Well, after we printed the largest digit, we want to ask, do you want to enter another input? And then again, we'll just do, we need again some variable where we now want to store if the user wants to do one more input. Or, well, maybe I do something like, and instead of yes or no, the user will input just Y for yes and N for no.
Simply because we can only deal with characters at the moment, so
yeah,
it should be good enough.
And now again, we need something to access here in this while condition. It can't be this yes or no. But now I'll just declare a new variable up here. One more input. Maybe let's set it to false.
So this is now a Boolean. So a Boolean variable can only take the values true or false.
Yeah. And your VS Code might complain that bool is undefined.
So we need to include this. This is not in the very basic C contained at the moment, only in newer versions. So we also need to include a library, which is the stdbool.h library. Same as for stdio, for instance.
Yeah, I think it's default in newer C standards.
But not in the standard that we're working with.
I'm not
No,
sure. Okay.
no, it's not contained. Sorry, only in the very newest.
Well, but if you do include stdbool, it will work. So we have this Boolean here, one more input, we set it to false. And then down here, when do we want to do one more input? Well, if yes or no is equal to Y, should I do it in an if?
Is
first?
this clear what Julia wrote now? So this yes or no equals Y. So this is a comparison between this yes or no and the Y. So this is done first, this comparison, and the result of this comparison is either 0 or false, yeah, if it's not true, or it is 1, which is true, but maybe also write it in an if.
Yeah.
It's probably better for the start.
Oh, okay, I can comment it out with a shortcut. So this would be the same as if you write if one more input is equal to Y, then we said, no, that's the wrong one. If yes or no is equal to Y, then we set one more input to true, and else we set one more input to false.
So you can write this in this one-line thing that Julia commented out before, or you can write it explicitly in this if-else. Both is fine, of course.
Yeah, because the thing we observe here is that yes or no equals Y already returns true or false, and instead of asking if this is true, store true, else store false, we could just immediately store the result of this in one more input. Okay, let's try it out. largest digit 6. Do we want to enter another input? Yes.
Oh,
Okay, now something didn't work. No digits in the input we get.
and we did not even get asked to enter another input. So the Y worked, but then we could not even enter another input. Has somebody an idea why this is the case? Yeah.
Yes. So before we use the input buffer to our advantage to go over the whole input character by character, but now the input buffer is somehow working against us. Because right now, same problem as in the very beginning. Yes or no, get char. I typed Y and then \n, so I pressed return. The Y is stored in yes or no. We check, we loop, but the \n is still in the input buffer. And the next get char we have is this one here, and it's immediately the \n. So we already exit the loop and print no digits in the input.
So the program doesn't ask for another input, and then we are again at the question if we would like to repeat this or not.
Yeah. So what we need to do here is, well, let's first consider another edge case. Namely, if the user directly presses return, then the \n is already in yes or no. So we need to do if yes or no is not equal to return. So right now, of course, the user can enter different characters than Y or N. And if the user directly presses return, then just the \n is in the input buffer. And what I want to do now here is that I want to call getChar as long as if the user entered a longer input, as long as there are still characters in the input. So I can do this with while getChar is not equal to \n. I want to read it, and yeah.
So
you don't even need to specify a body for this loop.
So we don't have the body in the while loop. We just look at the statement which is in the while and do this until it is not fulfilled. And it's not fulfilled if getChar returns the \n. And then we terminate this while loop and continue.
So let's try this. Another input, yes. And now it really asks us again, and we can enter a second input, and it also tells us the largest digit.
And if we type now no or n.
If we type n, then we exit.
If you maybe execute it one more time, some input doesn't matter now. What happens if we would, for instance, type yes now? If we would type yes as the input. Oh, sorry, now from keyboard layout. Yeah, yes, okay. What would happen now? Would we continue or would we terminate? Continue? Yeah. So we only look at the first character now.
Yeah, what happens? getChar returns the Y. We set one more input to true, and then we read all characters, so the E, the S, and the return, and continue with another input.
So if we would like to have this more strict, that we only allow a Y and an N as an input, and only in these cases continue one more time or terminate the program, then we need to do much more checks here. So we need to check, is something after the Y, if there's something after the N, what happens if it's neither Y nor N? So there are multiple things that we need to consider at this stage.
So,
currently we believe that the user knows what he is doing and he types the right thing.
Yeah.
But you can never expect this from a user, that he really does the thing that you intend. So there, you need to really account for all possible cases.
And as you can see, if I type something completely different, we also exit because we just check, is it yes or is it Y?
There was a question.
Could you maybe show the while loop again? Because
The outer one?
Mm-hmm.
Do you program on your device with us? You probably didn't remove in our line 17 that you probably said char current character and didn't use the same variable as before. Because if you have this situation, if you have the situation in line 14 and 17, these are two different variables.
Yeah, so you need to be careful. If we write char here, we create a new variable with the same name, which shadows the old one. So this is a new variable with the same name, and in here we now can't access this one. We only ever change this one, but in the while condition in here, we cannot access this one, therefore we check this one. Yeah, and therefore the while loop never stops. So we need really to do something like this.
To sum this up, only use variable names once in the function and not multiple times. Okay, but now this is, I think, working very nicely. Okay, so let's say we are done with that example, and so we have here also the code on the slides that you can then download after the practicals. And now we come to the topic that was discussed last time, functions and structuring a program. And I would like to comment now on your code a bit. So what have we done? All the code that we have written is in the main function. If you do this in the assignment, then your tutor, no matter who it is, will tell you all your code is in the main function. You didn't use any other functions. Don't do this. I will need to deduct points. This is not a good style. Yeah? So this is not working. All code in the main function is not a good style, and we will not do this in the course, except for today, because we want to present this. So in particular, what is all contained here? So we have this outer do while loop where we looped for multiple inputs. Then we had this reading the input. This reading the input part was also a loop, yeah, and we also had conditions, when do we stop reading, and so on. So multiple things were happening. Then we printed the result of the input, so the largest digit. This is not a large functionality, but it's also doing something. We also need to check, was there a digit, was there no digit? Also there is a check. And then we also had the topic asking for the repetition. So also need to read again something, print something, perform checks. If you want to extend it as only a yes or no, or y and n is working, this will be much more code. And this is all then together in the main function. And then at some point it will become unreadable.
Yeah, and maybe you already noticed this now. We had a loop within a loop, and then also some if statements, and then it's pretty hard to follow and actually see what's going on, because there is so much functionality within this one function, and we see all of this functionality at once, and yeah.
So this also holds true for the practicals. One function should contain exactly one functionality, and not two, and not three, and not more, exactly one functionality. Okay, so how can we now modify the program that this principle is fulfilled? And I will start again from scratch with an empty main, and I would like to code it now in a more appropriate way. Yeah. So what do we want to do? The basic structure here in the code is, okay, we want to read multiple inputs. So we have some do while loop here. Okay, keyboard layout, but now. So we have some do while loop doing something. And what should be done in this do while loop? The first thing, read an input. So we will write a function that reads an input for us. Or basically, I will just rename it that I already have the largest digit. So read the largest digit. Yeah? This is the first thing. And then the second thing is, I want to print the largest digit. So print largest digit. Next function. And then third functionality that we had here, okay, ask for repetition. And that's everything. This should be the main function. If you see the main function now, you see, okay, what does the program? Reads the largest digit, prints the largest digit, and then asks for repetition. And that is everything that should be contained in the main function. Because now you know what the program is doing without any further logic. I mean, we need to add a few things here that it actually works. So if we read the largest digit, of course, we need to obtain this largest digit and store it somewhere in the main function. So we need to create here a variable, largest digit, which is then the return value of this function. Of course, we need to store it in the main. And then at the next step, we want to print this largest digit. This function, of course, needs to know what the largest digit was. So we need to take the character that we created here and received from the other function and parse it now on to the print largest digit function. So then this part is already completed. And then this ask for repetition probably should return maybe a variable one more input. And since we will use it now in the while condition, I don't declare the variable here, but I do this outside. So again, have our bool, one more input, maybe set it to false at the beginning so that it is initialized. Then we ask for the repetition, and here we get either true or false, depending on what the user entered. All this is done in this function, and then we simply check in the while here, one more input. Yeah, while one more input, or we could say one more input equals true, but of course, one more input already stores true or false, so we can just keep it like this. And this is our main function. I will never touch the main function in the next 12 minutes again. This is everything that I need.
Yeah, and now maybe compare this main function to the main function we wrote previously. Maybe pretend to be a tutor who grades your code. Then if we see this main function, we already know more or less what's going on. But if we see some main function like this, it's much harder to follow, especially you start reading and then, okay, do while, and then another do, and if, yeah.
Yeah, so it's many things happening here. So this should be really the main function. But now we need, of course, to extend the program and write these functions here. So maybe start with read largest digit. And you learned then in the lecture, you declare the functions before the main, and then you can either implement them directly before the main or after the main. I will do this after the main such that the main function is on the very top. So read largest digit. So this is the function. We said already it should not take any parameters because what should it know? It should just read the digit, so it doesn't need any further information. So there are no parameters, and it should return a character. So this is the return value of the function, and this is the list of parameters, and if you write void here, this indicates the function doesn't take any parameters. Probably I will do this also for the other two functions. So print largest digit, so we don't store the return value of the function somewhere, so it should be void, there is no return value. Then we have print largest digit, and this function now should take a character, which it should print then. So character largest digit, and they ask for repetition. again, or it returns now a Boolean value, ask for repetition, and it again takes no parameters. So these are the function declarations. And now let me copy them and we'll define the functionalities below the main.
Yeah. In your assignment, you don't need to first declare the functions and then define them below the main. But I think it's good style, because then at the top you always see what functions you have, and you can also write your header comments that you need to write for every function at the declarations above, and you don't need them when you actually define what the function does.
So I do it now below, and the void function, okay, I will keep it like this for now. It's okay. For the character function, I will immediately define a return value here. So for instance, I return a 0 here, and for the bool function I return false, so that it has now a return value even though I haven't implemented anything here. So I can at this point run my program even if these functionalities are not implemented yet. So it will be probably not a very nice result. So if I run clang main, and now I want to compile main rework.c. It compiles, there is no error. If I run it, okay, nothing happens because I have not implemented the largest digit, I have not implemented the print or the ask for repetition. And now I think it's very easy to come up with solutions for these parts, because now we can look at the code Julia have written. So the input reading is basically only this part. We have declared the largest digit. We want to use it to enter an input, have the character, have the loop here where we repeatedly read, and update the best character. So this part moves then on to the print largest digit. So here, then indentation. If you mark something and press Shift-Tab, then the indentation moves back. So we have the largest digit, do everything here. And now what should we return? We should return a character. What is the appropriate value? The largest digit. So this is the best thing that we have found here. So we'll return the largest digit. So first function is done. And if you look at this function now, this is not very lengthy. It's just two variables declared here, a loop and a condition, but that's everything. It's not like 10 things happening. It's very clean now. Just one thing, iterating through the input and finding the largest digit. Now the print is even easier, print largest digit, because we just copy here the if-else part. Look at the style guide again. So luckily I have the correct variable name here as the parameter already, because now the largest digit, so maybe go a step back. In the main function with the read largest digit, we ask for the largest digit. This is the return value of this function. So this is what we return at the end of read largest digit. This is then stored in this character, and this is then passed to this function as a parameter. So the value that is stored in largest digit is then copied to the function print largest digit. So this is copied here. This is the second variable that has the same value as the variable in the main. With this variable, we can perform then the check, whether it's large equals 0, print it, or otherwise print that there are no digits in the input. So this already works. So we can even try it because we have a basic implementation of ask for repetition. Yeah, saving the file. We compile it. If you run it, ESB, this already returns 6, or if I don't enter any numbers, it returns no digits in the input. So this is already working. It's just missing this ask for repetition, and also this can be basically copied now over. So it's now the part from, do you want to enter another input until, yeah, we have cleaned up the input that was written by the user. So do again a bit formatting. So we print, we read the input. So we don't have now a variable one more input in this function. So we will create this Boolean here, maybe directly at the beginning. One more input, set it maybe to false. If yes or no is y, then we set it to true. Otherwise, we set it to false. Okay, we even initialize it in the beginning to false, so we can get rid of the else even, because we just set it to true if there is a y, otherwise it's already false.
Yeah, and maybe try to figure out why we need the else in my other program.
Yeah.
In the program before, you could look at this at home. Why do we need the else in this if in my previous program without functions? Yeah.
And then finally in this function, we of course don't need to return like this default value that I introduced before, but I specify now the right value, which is one more input. Okay. Let's try it again. Maybe some numbers, largest digit, okay. Then if we enter the y, we get to another input, again enter something. If we press an n, for instance, then our program terminates. So again, to highlight this now, in the old program, I cannot show you the whole code now. I need always to scroll through all the things here to be able to show you the main function. And in the rework program, as you can see on this screen, I have the main function. You can read everything. You have everything inside. If I move to the next function, also this is, I don't know, 15 lines, 20 lines. Now I can show it to you. You can see everything. You don't need to scroll up and down to understand what the function is doing. It's very simple how it is written here. And this also holds true for print largest digits. This is a very simple function, but also for the ask for repetition function. This is also a very simple function. I can view it to you now on the screen. I don't need to scroll. You can view it, you can see it, you can understand it. And that is basically the coding style that we ask you to do also in assignment 1 and also in all other assignments and hopefully also in your further programming career. Because in this way, you can understand your code and also others can understand the code. And this is in particular very nice.
Yeah. Maybe before we continue, I think we don't have enough time to do the last part that we planned for today. But what we might want to show you now, because you also need to do this at the assignment, is maybe we should write one function header to show them.
To mean documentation, yeah.
So how they are supposed to be.
So if you should document all the functions and one maybe pick the print largest digit function. We have a template for that, but I will just write it now by hand. Or do we have an autocompletion here?
If you do it in the line before the function.
Okay.
And then 3 slashes, I think.
Yeah. So I just typed 3 slashes here and I already got some template for that. Then we have this brief. So here we can write what the function does. This function prints digit or prints the digit largest value, the largest digit if it is a digit. Okay? And the parameter is a digit as a character. So now we have a sentence for the function. Okay, maybe we add a bit more here that it looks more nicely, but we have a template for this, so you need to do this in the assignment as well, that you document all the functions. So here we don't need to describe a return value. In another function like this function, we would not need to describe parameters, but we would need to describe the return value.
Yeah, you can find all of this in the style guide. And one nice thing is, if we did this for the print largest digit and then hover over it in in our editor, the description we just wrote, including the description for the parameters, is displayed as a box here. If we just hover over print largest digit. And this can also help you to better understand what your program does if you want to recap it, for example, right before the assignment interview, etc.
Okay, with that, maybe switch back to the slides. So the functions and stack part, we will do this next week. This is important. Maybe there is even some more knowledge than known from the lecture. So just to sum up what we have seen, so we started with the uninitialized variables and Valgrind. So keep out for Valgrind, watch out for Valgrind in assignment 1. And then we talked mainly about the input of characters and also this input buffer thing, that if you enter something, then everything is passed to the program and not just a single character. And in particular, the \n that you enter as well, you need to consider this. And then we talked about functions and structuring a program. And please really, really do this in the way we discussed this. Please structure your program, in particular assignment 1 in such a way that it is readable, that the functions are short, and it's good for you and it's also good for us when we correct it. Okay, then.
And don't forget the question hour on Monday.
Yeah, the question hour on Monday, if you have questions for assignment 1. Then thanks a lot, and the lecture will start in about 13 minutes.